Okay, so question 2a, they give us the function, and then they give us a value for x. Okay? So that's the difference here. So they're telling us x is 0. So that means I'm substituting 0 in for both of these. I'll do it step by step, but I'm going to tell you right now, this 0, because these are all multiplication, is going to cancel all of these out.
All of it?
Yeah, so I'll show you exactly what that looks like.
I thought you did the exponent first, so it just takes it away, so wouldn't it be 2?
Watch, ready? So we do squared minus plus 1, right? So, first one, 0 squared is?
1.
What's 0 times 0?
0.
Yep. So then I'm left with 2 times 0. What's 3 times 0?
0.
0. So plus 1. 2 times 0?
0.
So I have 0 minus 0 plus 1. Just 1. Okay, so question E. What they've done, instead of x, we now have to substitute 2x in for the x's, and then simplify.
I know I did it wrong.
Do you?
I didn't put a square sign on it, so I added the... I don't know why I did a second step. I got the answer.
Alright, forget E, we'll do F. So, again, they are substituting 3x in for x. So, we're going to put that into the equation. 2x times 3x squared minus 3 times 3x plus 1. 3x times 3x. That's what essentially it says on the outside. So what is 3x?
Or, is it 9x?
Yeah, 9x.
Squared.
Yeah, 9x squared. So this becomes 9x squared minus, yeah, 9x plus 1. We bring the 2 in, we get 18x squared minus 9x plus 1. Okay, 6a. They've given us a quadratic equation. Right? Now, I don't know if you remember how to graph these by looking at it. But right now, it's in vertex form. So because it's in vertex form, we can actually just go straight ahead and graph this. There we go. Okay, so we have our graph. In vertex form, I don't know if you remember this equation, but it's similar to y equals a x minus h squared plus k. Okay. H and k deal with the vertex of the quadratic and moving it left to right and up and down. So the k goes with up and down. So because k is plus 1, normally our parabola looks like this. We start at the origin. This would be if the function was y equals x squared. Okay. Start at the origin, we go over 1, up 1, over 2, up 4, over 3, up 9. Does that ring a bell for you?
Mm-hmm.
Yep, 9. So we have, this is their regular model. Okay. So because again we say k is positive 1, so the vertex moves up 1. So now here, and h is negative 3. The only difference with h is we go the opposite way that it says.
Go 3 ways.
Yeah, so we're here already, and we go over 1, 2, 3. So here's our new vertex. It's at 3 and 1. Okay, so that's where the vertex is. And a just deals with stretching it. Okay, so if we had to draw it, we'd obviously have to stretch. We go over 1 and then up 1 times 2, so we go up 2. But what we're really working on is domain and range. So technically, we don't have to draw this perfectly. I'll show you. Over 1, up 2. Over 2, normally we go 4, so we multiply that by 2. We have to go up 8. So we'd be at 9. So we have a parabola that is thinner than before. Okay? But what's important here is the domain and range of this function. So, first of all, our domain. Okay? Our domain is what? Does this parabola go left and right forever? Yeah, it'll go forever. So we already have this element of the real numbers. So we know the domain is going to go on forever. There's no restrictions. What about our range? Range deals with the y-axis. Y. Yeah, y's got to be greater than 1. Now, technically, because it's a continuous function, we always got to start with y is element of all real numbers, and then we put our restriction, such that y is greater than and equal to positive 1. And that's our domain and range for 6a. Does that make sense? Okay, so first off, Do you know what this function normally looks like when it's graphed? That's why.
It's either the one that's half the parabola or the two. I don't remember.
Yeah, so we essentially have something that goes like this. It approaches up here, comes up, goes like that, and its restriction is on 0. And then it exists here and then goes this way. Have you seen a parabola like that before?
Yeah.
Okay, or not a parabola like that, a function like that before?
Mm-hmm.
Let's see, zoom out. Okay, we can see a little better. So we'll draw this as our skeleton. Goes like this, up, boom. Function goes like that. It has a restriction on 0. It doesn't exist there. Okay, and same idea comes up towards here. So this will never touch the x or y axis normally. Okay. Now what has happened is this function has moved. We have plus 5. So what that's saying is this function is moving, and it's in a direction of, do you know if it's left to right or up and down?
No, left to right.
Yeah, so we got up, left, and right.
The outside of the...
Yeah, it's got to be outside. It would have to be outside like this, plus 5 to be moving up and down. Because it's a part of the x, it's underneath the entire division sign. Now, where is our restriction? Do you know by looking at this?
It can't be equal to -5.
That's right. It can't be equal to -5. Okay? Because if x is -5,
Is that the domain or the range though?
this is the restriction.
It's the restriction, but it becomes...
It'll be in the domain and range. It's part of it. Which one? You'll see in a second. You'll see in a second.
X.
Because it's dealing with x, it's going to be the domain. So there'll be a restriction in the domain. Now, it can't be -5, because if it's -5, the bottom of this will say 1 over 0, and that's impossible. We can't do such a thing. So we have a new function at -5. So let's draw a little restriction line here at -5. So essentially, it can't touch this. So we have roughly the same function. It's going up like this, and then comes up and around like this. It's not supposed to be touching the line there, but that's it. Okay. So our restriction is on -5 right now. So when we go to write the domain and range, our domain is going to be what?
XCR.
Yeah, XCR.
X is greater than -5 or less than or equal to? No, it cannot be like X.
Not equal to
-5.
-5. How about the range?
Y cannot be equal to 0.
Yeah. So
Can you actually have something on the top though?
can you have something on the top? What do you mean?
Like what? It's just 1 all the time. Is there ever anything on the top?
Oh, okay. That would be like multiplying by a. This function is essentially our, think of that as our a. This would be kind of like the h. So I have h. And then we have a k on the outside. And technically you can actually affect this as another variable in here that changes the way it's stretched. But if we're relating to like kind of the vertex form where the a stretches it, h moves left and right, and k moves up and down, that's the idea. So if a was a number, then I can multiply it in, and 1 would change, right? So it would change the way that this parabola, like I haven't drawn it perfectly, but it's going to touch different points on the graph. We're just doing the general overview of it right now.
So it can have restriction.
Okay, so normally this function kind of looks like this. We'd have a y equals the root of x. And that would be looking something like this. 1 over 1, 2 over 4. Yeah. Now, the reason they make it a half parabola is because they want it to be a function. Technically, when I square root x, I have 2 numbers, positive and negative. So I have
it's that way.
Symmetrical like this. Well, because they want this to be a function, if it's like that, it doesn't pass the vertical line test anymore. So we're only dealing with the top in order to make this a function, okay? So we don't deal with the bottom right now.
Is it like if it was, then they put plus or minus?
so we're going to complete the square. First of all, we can simplify because we have two like terms. Yeah, so we get y is equal to 2x plus 7x minus 30. Second off, because there is a number, a coefficient in front of x, we need to divide these two by that number. We don't have to deal with the 30 because we can keep it outside of the brackets. So essentially we have imaginary brackets around that. So when I divide, I get 2x squared plus, and we leave it as 7 over 2x minus 30. Now what we need to figure out is what number we're going to add and subtract inside the brackets. So we take 7 over 2, and we technically divide it by 2 and square it as the idea. So if we're to divide it by 2, what this actually becomes is 7 over 4. Does that make sense? I skipped a step there, but that makes sense to you? Okay, so we have our 2, and technically we divide by 2 and then square. So this becomes 7 over 4 squared, 49 over 16. That make sense? Okay. So we get x squared plus 7 over 2x. Which one do we keep inside again? I always forget. The positive, right? Positive 49 over 16. And then, actually, I'm going to keep the negative 49 over 16, just to do one step at a time, minus 30. Okay.
These steps confuse me.
Well, we're just putting them both inside the bracket, so one at a time. So we got our number, and we add and subtract it. It's like adding 0 to an equation, right?
I know, because then after that, then I have to divide it to figure out which number it is in the middle. It's just, I understand like now, but I mean like just doing it step by step. I would kind of just randomly just put the thing in the middle.
Alright, well, if you find it easier that way, I'm just going to go through it step by step so you see everything. And when we bring this out, we got to multiply by that. So it becomes 2x squared plus 7 over 2x plus 49 over 16. And then subtract 98 over 16 minus 30. Okay, does that make sense? And then here we know that because that's a positive sign, we can break it into x plus, and the square root of this is 7 over 4. And we put the squares. The only thing we have to deal with left is the negative 98 over 16. Yeah, so we're going to make a denominator for 30 over 16, so I'd have to multiply 30 by 16. That's going to be 480. Is it 480?
I reduced it to 8.
Oh, okay, you reduced them into 8? Okay, I'll do that in a sec. So I'm going to get 480 over 16. So we get 2x plus 7 over 4 squared. Let's do a negative 98. There we go. So we have 98 negative minus 480. 7578. So we get negative 578 over 16. And then what did you do to reduce it? Divide them both by 2?
When I did the beginning, I just crossed out instead of multiplying it, just crossed both of them out.
Okay, so if we divide this by 289, sorry. 289 over 8. That's what you got. So this function, number 10, is essentially just a straight line from corner to corner. So it's a 45-degree angle. That is f at x is equal to x. They want you to translate this line up. What does it say? Up 3 units and to the left 2. So essentially we're taking, it goes right through the origin. It goes 1, 2, 3. and to the left 1, 2. Okay? So they want a new line. The slope has not changed. Line goes like that. There's our line. Slope's the same, and if you remember y equals mx plus b, our slope is still the exact same. So it was just 1, so y is equal to 1x, which is x. B is our y-intercept, okay? So our y-intercept in this case happens to be the number 5. But a way to find that by plugging in is, just remember, technically our functions can always be done like a. What do we say? 2 to the left? With positive 2, so minus h plus k, right? We said that they weren't changing the slope of the line, so a is still 1. We were going 2 left, so it becomes positive 2, and up 3, positive 3. So essentially we got a is 1. Do you want me to write that in? Okay. So we got x plus 2 plus 3. And when we simplify that, what do we get? Well, we don't have to do anything with the brackets. They just happen to be there because of the way we're used to writing this function. We can just drop the brackets. So we get x.
Or do you have to add them both together?
Yeah, we got to add them together.
Plus 5.
X plus 5. And remember we said that our y-intercept is positive 5. So there's 2 ways to do it. I could have graphed it and found what the y-intercept is, or I plugged in, I went 2 to the left and 3 up for my h and k, and then I just simplified the function for a straight line. X
so
plus
that's
5.
negative?
What's that?
That's negative.
That is x plus 5. Well,
Could
f
you-
at x is equal to x plus 5. Okay, so yeah, you're right. We have a parabola right now. It's at the origin 1, 1, 2, 4, 3, 9. So this is our f at x equals x squared. This is our original one. Now remember our model again, where we have f at x is equal to a x minus h squared plus k, right? The only difference is we had a squared now. A deals with being stretched. So what did they say? Stretched by a factor of what? 5. So we know that a equals 5. Moved how many left and right?
Translated 2 units down, so that's the k.
Down 2. Okay, so k is negative 2.
1 unit left, so positive.
Yeah. Now do you know why it becomes positive 1?
Does it have to change to its opposite sign?
Because technically h is negative 1.
But you take it out.
Well, though, when we put it in,
Oh, yeah, you put it in there too.
minus 1 becomes
Becomes
positive
positive.
1. Does that make sense?
Yeah.
Okay. So, oh, one last thing. What did they say happened to it? It got...
It's reflected on the x-axis, so that means it's the, I don't know what value it is for this one. H? Not H, but in front of x, like k.
Okay, it can be the A.
It can be A?
Yeah, it can be the A in this
But
one.
isn't A vertical, which is Y?
It has to do with stretching it. Okay. This one is not as complicated as the other functions where we do get one more. Because there's nothing in between the x, I know what you mean, we can add another function to it. What will happen is the A actually becomes negative.
Okay.
So we get negative 5.
Only for this one, though.
Yeah. X plus 1 squared minus 2. So that becomes our function. So essentially, our new point is to the left 1, down 2. So here's our origin. It's going downwards and stretched by a factor of 5. So we go over 1, down 5. Over 1, down 5. So we have a new parabola that looks like this. Okay?
Okay.